So in the last class, I explained you, in fact, I gave you the steps to solve the questions which had to find the inverse of a matrix with the help of adjoint method. So let's continue with that today, guys. Yesterday we had seen a question which was based on a 2 by 2 matrix. Now today we will understand how to solve it for a 3 by 3 matrix. So just keep the steps that I gave you yesterday, the page where you have written the steps, open right there in front of you. And I'll apply all those steps one by one, and then you can copy down from here later on, no issues. So just see, I'll take a simple example first of all. The example says to find inverse by adjoint method. And the matrix A that I have is something like this. Let me take a easy number. 1, 2, 0, 3, 5, 1, 2, 7, and let us say -1 for example. Some random numbers I have taken, and I have to find out the inverse of this particular matrix. Let me see what the answer comes. So if you open and see the steps which I have given to you, the step number 1 over here says that you have to check if the inverse exists or not. In order to do that, I have to first of all calculate the determinant of the matrix A. So let me do it. 1, 2, 0, 3, 5, 1, 2, 7 and -1. So if I have to calculate the determinant of this number, it's very easy actually. Let me write it over here. I should get it as 1 multiplied by -5 -7 minus 2 multiplied by -3 and -2, and plus the last element is 0, so we can just ignore that. So leave it. 0 into anything will be 0 only. So we don't need to calculate that. But in case if you want to know how to do it, so the method is like this. 0 will get multiplied by 7 into 3, that is 21, minus 5 into 2, that is 10. But ultimately it will be 0 only in this particular case. So this becomes 1 into -12, that is -12, minus 2 into -6, sorry, -5 it is, -2 and -3, that is -5, and ignore the last term which is 0. So this is -2 and plus 10, which is equal to -2. This is not equal to 0, and by default I can say that therefore A inverse will definitely exist. So I have got the answer as A inverse exists. Now because A inverse exists, I have to calculate the adjoint of this matrix first, and then I have to calculate the inverse. In order to calculate the adjoint, I have given you the steps which says that you have to first of all calculate the cofactors. Let us write the formula for cofactors. I will get over here. Cofactors has a formula Aij, which is -1 to the power I plus j multiplied by mij. Now, when I want to calculate the value of A11, please focus over here everybody guys. If anybody is writing, please do not write it. First of all, understand this. A11, it is equal to, okay, let me write over here. For A11, I will write in the bracket I is 1 and j is also equal to 1. So when I want to calculate A11, I will get it as minus 1 to the power 1 plus 1, which is 2, multiplied by M11. Now minus 1 square is going to be 1 only, so I can just write over here 1. But now guys is the most important thing for us to understand how to find the value of M11. Just open the steps that I have given to you in the previous lecture, and we have written over here the statement like this. The minor in case of a 3 by 3 matrix is nothing but the determinant of the elements which are left after covering the ith row and the jth column. So what does it mean? In this case, I is 1 and j is also 1. So therefore guys, I have to cover the first row as well as the first column. So if you cover first row and the first column, I will get, let's check it out, minus 1 into 5, that is minus 5, and minus 7. So yes, you are absolutely right. The answer is negative 12. Very good. That is about my value for A11. In the same manner, let us calculate one more value. In fact, we have to calculate all the cofactors for all the 9 values which are available. So let's do it one by one. If you have A12, so in the bracket, I will write I is 1 and j is 2. So therefore guys, I will get over here A12 is minus 1 to the power 3 into M12. Now guys, I is 1, j is 2. So it means that I have to cover the first row but the second column. So when I cover this, I am having 3, 1, 2 and minus 1 as the 4 elements which are left for calculating the determinant. And therefore guys, I will get this as minus 1 multiplied by minus 3 and minus 2. It's 5 beta over here. Minus 3 and minus 2 is minus 5 multiplied by minus 1 अगर आप करोगे तो वो 5 आ जाएगा. Am I right? Okay, so this is A12. Good. So let's calculate one more value. A13. Now I guess you guys are comfortable, so I can do it quickly. I is 1 and j is 3 this time. So let me just cover off the first row, but this time the third column will have to be covered. So therefore in this case guys, I will get A13 is equal to minus 1 to the power 1 plus 3, that is 4, and M13. So this is 1, and if I just do the calculation, 21 minus 10, this comes out to be equal to 11. So therefore guys, A13 comes out to be 11. Now this procedure has to be repeated for the second row and the third row. Let me once again do the same thing for the second row as well as third row. I will write over here A21. So in the bracket, I have to write I is 2 and j is 1. So carefully, if I want to find A21, it is minus 1 to the power 2 plus 1 into 3 multiplied by M21. This is going to be negative 1. And let me cover off. Okay. So I will get second row and the first column. So I get the value as minus 2 and minus 7 into 0 is 0. So I get just equal to 2. That is absolutely right. A21. Let's calculate the next. A22. I think now we can try to do it orally, because in exam you will not be expected to write I and J separately. So now let's try to do it mentally. Let's be a little quick now. A22 will be equal to minus 1 to the power 2 plus 2, that is 4, and M22. This is 1 multiplied by. This time I have to cover the second row and the second column. So I will get 1 into minus 1, that is minus 1, and 0 into 2, that is 0. So I will just get it as minus 1. For the last, A 2 3 minus 1 to the power, let me write it in the next line, minus 1 to the power 2 plus 3 5 multiplied by m23. So this time friends, you have to cover the second row but the third column. So this time I have to be careful because there are 4 different numbers. So this is negative 1 multiplied by 7 minus 4, which is minus 3. I hope I am quite clear to all. This is your required value for A23. I now want everybody to copy this thing down and I'll give you 2 or 3 minutes time. I want everybody to calculate the cofactors for the third row on your own right now. Do it. So let's write the value for A31, A32 and A33. Please tell me guys. Okay. And what is A33? 0. Okay. I believe everybody must be getting the same answers. Anybody getting something else? Some different answer for this? All are on the same lines? Okay, fine. So now guys, we are done with our cofactors. So this A33 value is minus 1 as per what you are telling. So it's okay. We'll write this as A33 as minus 1. And now guys, we are all ready with the cofactors. Now we have to make the cofactor matrix, then the adjoint and then the inverse, and we are ready with the answer. Let's do it quickly. Come on. So I will write over here. Therefore, cofactor matrix is. Now it's very simple guys. You just have to write all the cofactors in their respective positions. The first row elements right there in front of you. Minus 12, 5 and 11. One more thing. Always try to present in this manner only. All the first row cofactors together in the first row. The second row cofactors like we have written over here in the second row. And the third row cofactor right below that. So that when you write it in the matrix, you won't make any errors. And you won't have a confusion ki which value has to be written in which place, because all of them are already arranged. You just have to copy it from up in the matrix format bus. Okay, so it's a best idea to do it like this: minus 1 and minus 3, 2 minus 1 and minus 1. So guys, that's your cofactor matrix. If you guys remember from the previous class, I had told you that adjoint of a matrix is nothing but, yes, transpose of cofactor matrix. So that is nothing but negative 12, 5 and 11. I have written the first row as a first column. 2, minus 1 and minus 3. The second row over here becomes the second column. And finally, the last row becomes my last column, 2, minus 1 and minus 1. And yes guys, we are almost done with our answer, because the formula for A inverse is 1 upon determinant of A multiplied by adjoint of A, and you already have the determinant, you already have the adjoint, you just have to use those values from the up. What was it? Let me see that. Yeah, so here it is negative 2 is the determinant value of A. So I will use this 1 upon negative 2, and this matrix will be just copied down without any change, no issues. 11 minus 3 and minus 1. I hope it's very easy. If you guys remember, I told you that the previous sum was for 3 marks. This may come for 4 marks because it is a 3 by 3 matrix. And if it's a 2 by 2 matrix, that may come for 3 marks. So I want all of you to try to solve question number 5, the first one and the third one on your own right now. And question number 3 and 4 will be for homework for everybody. Okay, just give it a try. If you have any questions, you have my number. You can always message me or contact me. Okay, so please do it, guys. So this is our answer for A inverse for the first sum and the A inverse for the third sum. Now, okay, 1 upon 18. Okay, okay. So that's the required inverse of the second question. So now let us see how we have to apply this in our uh, other parts, or in fact the other exercises that we have studied in this exercise, the adjoint, the inverse by the adjoint method. The application of matrices is done when we want to solve the linear equations, I should say. I'm sure everybody must have heard about the Kramer's rule in your smaller classes, in your 9th standard or 10th standard maybe, where you had to solve the linear equations to get the values of x and y. So when you come across two different equations, let me take an example. Suppose if you have and 7x plus 4y is equal to, let us say, 20, example or equation number 2. Then guys, in this case, uh, there are different methods with the help of which I can solve these equations. If you remember from your smaller classes, we can solve it using method number 1, elimination method. Method number 2, using the substitution method. Method number 3, using the cross multiplication method. All those who have done their 10th standard from CBSE board must be knowing this. For others, this method is not there in the 10th standard. For the state board, I don't think for ICSE as well. But yes, CBSE has this. So if anybody of you have done it from CBSE, you must have heard about this method. And the number 4 method is the Kramer's rule. और ये जो क्रेमर्स रूल है, दिस इज देयर फॉर द स्टेट बोर्ड स्टूडेंट्स बेसिकली इन द 10th standard. ICSE or the CBSE doesn't have this Kramer's rule, so it's okay. Whatever it is, these are all the different methods that you have studied or finished in your smaller classes. Now for your 12th standard, you have to learn how to solve this kind of equations using matrices. So when I want to solve the equations using matrices, you can write down this along with me, please. To solve linear equations using matrices, uh, there are two methods. The method number 1 is the inversion method, and the second method that we have is called as where it is, yeah, method of inversion, as I already told you. And the second method that you have is called as the reduction method. Yeah. So see guys, one very important point that you need to remember over here. The inversion method is based on finding the A inverse, and this is based on reducing the given matrix. Now don't worry, we will be discussing both the methods in complete detail, but just for you to give a hint, for you to remember that if in the exam, in the question, you come across solve the equation using inversion method, then you have to actually calculate the A inverse using the adjoint method. If you want, you can do that using the transformation method, but we have not yet studied transformation method. Sorry, we will be learning transformation method in the next class. But when I want to find out the inverse of a matrix, easiest way is always the adjoint method. Therefore, I am covering it along with the adjoint method over here. Now, when you talk about the reduction method, it is a different method altogether. So we will discuss it when we are doing it in a separate class. For now, give the heading everybody inversion method, and please write down the steps as we had done it in the last lecture. And I'll give you some examples so that you understand how to apply this method. Steps. Step number 1. Express given equations in the form of a matrix A, X, and B. These are the three matrices that we will be creating from the given equations. How do we do that? Let us write it. A is matrix of coefficients of let me say LHS in given equation. Matrix X is the matrix of variables. Always remember, matrix X is always a column matrix, compulsory. I'll explain you the reason with the help of an example. If I just say right now, you won't be able to understand it, so don't worry. I will tell you why it is a column matrix later on. And the matrix B, this is the matrix of RHS values. Again guys, this is also a column matrix. I will come to it when I am solving an example. Point number 2, write equation AX is equal to B and give it as equation number 1. We have to mark it as equation number 1 literally. Why do we have to do it? I will explain you in some of the further steps. Just copy down the steps, don't worry. Point number 3 or the step number 3. Find A inverse. Step number 4. Pre-multiply equation 1 by A inverse. Now what is this exactly? Pre-multiply. It means that I have to write over here like this. A inverse into A into X is equal to A inverse into B. Now there is a very important reason for this, why I have to pre-multiply. Again guys, I will come to it with an example. Please copy down without having any doubts or any problems, don't worry, I'll come to it in the example. Why pre-multiply and what is the meaning of it? Okay. Now, when we talk about A inverse into A, if you remember from the definition of A inverse, I had told you that A into A inverse is always equal to I, where I was an identity matrix. So here I will be replacing it with I into X is equal to A inverse into B, and therefore guys, X is equal to just A inverse into B. The value of I is always assumed as 1 because it is a unit matrix or an identity matrix. So I just ignore it because multiplying by 1 gives us the same result. So we don't have to sit and multiply it again and again. So the example for this is solve 2x plus 3y is equal to 6, x minus y is equal to 10. Say for example, these are the two equations which are given to us. I have purposely taken simple equations because it is the first example. But yes, I would expect everybody please concentrate over here. Please keep the page where you written the steps in front of you, open in front of you. Don't copy it right now. Refer to the steps and see what I am doing over here. And then you can copy down later on. I'll give you time to copy it down afterwards. Okay, so first of all, see. Step number 1 over there says to you that express the given equations in the form of a matrix A, X and B. I have told over there very clearly that A is the matrix of the coefficients of the equation on the LHS. So guys, matrix A is taken like this. 2 and 3 from the first equation, 1 and minus 1 from the second equation. I am sure you can identify this. If nothing is there, then obviously 1 has to be there in that equation. Therefore, I am taking it like this. 2 and 3 from the first equation, 1 and minus 1 from the second equation. After that, the next is your matrix X, and I had very clearly written in the above steps, it has to just be a column matrix. What is the reason for this? I am coming to it, don't worry. Then the matrix B is again 6 and 10. Obviously, as you can see that 6 is representing the first equation and 10 is representing the second equation. Therefore, I have written it like this as a column matrix. So I told you the reason for matrix B being a column matrix, that it is representing the first equation and the second equation. I have not told anything about X, right? X up till now. I'll tell it to you just in a minute. So guys, that was our step number 1. If you see up over here, I have expressed the given equations in the form of the matrix. Next is write down the equation Ax is equal to B. So we will do that now. And I have to write it as equation number 1. Now comes the reason why is X a column matrix. See, I will just show it to you. Don't write it because I am myself going to erase it off in some time. It is just for understanding purpose. We don't write and show this in the exam. See this. If you have the equation or the matrix A 2, 3, 1 and minus 1, and I have X as suppose X and Y like this, it is very clear that the first matrix is of order 2 by 2, second matrix is of order 2 by 1. So you remember the property of multiplication of matrices, which says that the number of columns in the first matrix has to be equal to the number of rows of the second matrix. So if I take the matrix X as a column matrix, only then this property is going to get satisfied. Instead, if by chance you write it like this, 2, 3, 1 and minus 1, and if I write X and Y horizontally, then there is a very big problem. What is it? A doesn't have any issue. It is still of order 2 by 2. But this time it becomes of order 1 by 2, 1 row and 2 columns. Now over here guys, there are two rows and only one column. Therefore multiplication of these matrices is not possible. So this condition will completely fail if I don't take the matrix X as a column matrix. Therefore guys, we have to remember here that matrix X is always a column matrix and it is never a row matrix. So I hope everybody has understood that why is X a column matrix. Now this is our equation 1. So we are done with 2 steps. Guys, first step was expressing the equation in the matrix. We are done with that. Second step is that we have to write the equation. We have also done that. Next step is to find the A inverse. I am sure everybody is now very comfortable in calculating the A inverse of a 2 by 2 matrix. So let's quickly do that guys. But don't forget, if I have to find out the inverse of a matrix, you have to always check for the determinant. So let's do it first. 2, 3, 1 and minus 1, minus 2 and minus 3, that's minus 5. Of course, not equal to 0. Therefore, A inverse definitely exists over here. So because A inverse exists, I will quickly find out all the cofactors. First, always write the formula without fail. Aij minus 1 to the power I plus j into mij. A11 minus 1 to the power 2 into minus 1, which is negative 1. A12 minus 1 to the power 3 multiplied by m12. First row and second column if you cover, it will be same, minus 1 into 1, which is again minus 1. A21 minus 1 to the power 3 multiplied by m21. This is negative 1, and if you cover the second row and the first column, you will get the value as 3. So the answer is negative 3. A22 minus 1 to the power 4, which is 1 multiplied by, what is it? It is just 2. So the answer is 2. So guys, therefore the cofactor matrix is equal to minus 1, minus 1, minus 3 and 2. And therefore adjoint of A is the transpose. This is your adjoint. And inverse, I am sure everybody knows the formula by now. 1 upon determinant of A into adjoint of A, which is 1 upon minus 5, minus 1, minus 3, minus 1 and 2. Now guys, see, remember one thing. In the previous certain example, I told you that you can leave the fraction as it is over here as 1 by 5. It's completely acceptable. There is no harm in this. But there is one thing that I can do. There are lots of minus signs that I can see. And if there are lots of minus signs, there is a high chance of making lots of errors. So what I will do over here is, I will just leave this 1 by 5 as it is. But if I put that minus sign inside the matrix, it will become 1, 3, 1 and minus 2. So now this looks more better because almost all the minus signs have been removed from inside of the matrix and only one minus sign is left compared to the above step, which was having 3 minus signs inside and 1 minus sign outside the matrix, which is again a problem. So I just did this in order to avoid my mistakes in the further step, which may happen due to lots of minus signs. So you can do the same thing, guys. So it's up to you if you want to do this step or not. It's not a compulsory step. If you are very confident that you are able to cope up with the minus signs, don't do this step, skip it. But if you feel that you are not so much comfortable with the minus signs, I recommend always to do this. So it's always better. Okay. So this is your value of A inverse. After getting A inverse, guys, let me go back to the page where we have written the steps. We are just now left with the last step, step number 4. Let's do it quickly, which says that pre-multiply. This is a very important word, pre-multiply. Now you will understand the importance of this. Just see. I will write over here, pre-multiply equation 1 by A inverse. I have already written the equation 1 over here. Where is it? Yeah, here it is. So I have to write A inverse into A into X is equal to A inverse into B. So here, this is very easy. This is obviously I into X, but main part is this 1 by 5, 1, 3, 2, and sorry, 1, and then it is minus 2. And B was, what was it? 6 and 10. Yeah, 6 and 10. I into X is just X. So guys, I will write X only. But yeah, now I will explain you the reason, the main thing. Why are we writing this word pre? I can just say multiply equation 1 as we always do. In general, we never say pre-multiply or post-multiply. We just say multiply. Why am I saying specifically pre-multiply? So see now. Suppose if I don't do pre-multiply and if I write the A inverse after B, then there is a very big problem. See what is the problem. Your matrix B into A inverse will look something like this. 6 and 10, 1, 3, 1 and minus 2. I am not worried about this fraction because 1 by 5 is a constant number, scalar multi number, which can be written anywhere, either over here or over here or over here. So it does not affect me at all. I am more concerned about multiplication of the matrices. So the problem over here is that, guys, the matrix B is of order 2 by 1. This is of order 2 by 2. Number of columns of the first matrix, number of rows of the second matrix do not match. Because they do not match, this multiplication is not possible. This is the reason we have to always say pre-multiply, with the help of which you guys will remember that A inverse should always be written first and then B should be written. Never write B into A inverse, always write A inverse into B. So let's multiply. Yeah, so I will just leave this 1 by 5 for now and I'll focus on the matrices. So as we always do, 1 multiplied by 6 and 3 multiplied by 10, and then usual addition of the numbers. So I will get 6 plus 30 for the first row. Again the same procedure, 1 multiplied by 6, but minus 2 will be multiplied with 10 this time. So what is it? It is 6 minus 20. So what is your X? It is actually the matrices, sorry, the variables X and Y. 1 by 5, 36 minus 24, which over here X, Y, 36 by 5. Oh, sorry, you are right. Sorry, my mistake. Minus 14. Thank you. So yeah, now the last step according to which I will say by equality of matrices. X has a value 36 by 5, Y has a value minus 14 by 5. It's very easy sum actually, guys, because we are doing the first sum. You found it to be, maybe you found it to be long and time consuming, but actually it is not. It can be completed maximum in 3 or 4 minutes. And if it is a 2 by 2 kind of a question, it will come for 3 marks. But if it is of a 3 by 3 kind of a question, it can come for 4 marks as well. Okay. So depends on the question that is given to us. You can write that answer over there.